Okay, let's start again, okay?
In this video tutorial, we will perform load analysis, moving load analysis.
Okay, maybe this is the second part. We need to run the first part first, okay? So just wait a minute. How to make a model?
Video, we will model a concrete and steel tutorial video, we will model a concrete and steel composite bridge using SAP version 14. We'll start with a new model using the blank template. Now, first step to use the bridge modeler is by defining layout. We'll go to bridge, define layout lines, add new layout lines. Now here we will select unit of keep fit. The end station will be 1210 and the start station will be at 990. We can see the layout line in plan and elevation. For a quick start horizontal plan, we can select the existing template. For this example, we have straight template, and for the elevation, we have also built-in templates from where we can choose quick start layout. Press OK and OK. Now the next step is to define the bridge deck. Bridge deck section. Add new deck section and we will choose steel and concrete section. Now here we have the default section of the girder as F section 1. We have to change this to W36 into 230. So for this we will go to modify, show material properties, section properties. Select the frame section, add new, import new section, select wide flange, and from the floor go to AISC 3.4, and from the list select W36 cross 230. Okay. Now the frame section is important. Now from here we can choose W36 cross 230. We'll change the number of girders, interior girders to 4, and we'll keep the spec.
Is it possible, sir? Will you record the session?
Yes, yes.
You need to go now.
Not here guidelines.
And select W8 crossing.
Okay. Start from the beginning.
And steel composite bridge using SAP version 14. We'll start with a new model. using the plan template. The first step to use the bridge modular is by defining layout. We go to bridge, define layout lines, add new layout lines. Now here we will select unit of get fit. The end state will be 1210 and the start station will be at 990. We can see the layout line in plan and elevation. For a quick start horizontal plan, we can select the existing template. For this example, we have straight template, and for the elevation, we have also built-in templates from where we can choose a quick start layout. Press OK and OK. Now the next step is to define the bridge deck. Bridge deck section. Add new deck section and we will choose steel and concrete section. Now here we have the default section of the girder as F section 1. We have to change this to W36 into 230. So for this we go to modify show material properties, section properties. Select the section, add new, import new section. Select white flange and further forward go to AISC 3.4 and from the list select W36 cross 230. Press OK. Now the frame section is important. Now from here we can choose W36 cross 230. We will change the number of girders, interior girders to 4, and we will keep the span length. We will also change the span length. For this example, we will keep the span length equal to 36 feet. Now in this view we have the section which we have made from the template, and of course the section is now red. We press OK and OK. The next step is to define the diaphragm. Go to bridge diaphragm. The diaphragm and new diaphragm. This diaphragm will be based on chord and braces because it is a steel bridge, and we will select for this the cross 10. Press the plus button, import new property, select steel W section, AISCE 3.0 and select W8 cross 10. Press OK and OK. Now here the section is important. We can select for the top chord, for the bracer, and for the bottom chord. Press OK and OK. The next step is to return the train. Change bearing, add new bearing, and here enable the translation in use connection free. Now this code can be made from link support property which is already defined, but here I am going to define by the user definition and allowing the U2 translation. Press OK and OK. After doing foundation spray, add new foundation spray, and we will keep all the support as fixed. Change the property for the length and area as 1. Press OK and OK. We can change this name for easy to recall. I'll change the name as foundation spray. The next step is to define the abutment. But before defining abutment, we need to define the frame section for the abutment. So define section, frame section. Add new block. Select concrete rectangular section. The section will have a depth of 4 and width of 2 feet. And change the type to B. If you change the type to column, it will also calculate the movement too. So column type will give more result, more better result, because it will calculate the movement too as well. So press OK and OK. Change the name to abutment. Four cross 2. Now go to bridge, abutments, add new bridge abutment, and the name of the abutment will be abutment. The support condition is such that it is not the integral, but the parallel border is connected with the abutment only. If you select integral, the abutment and the girder are a single object. While selecting connect to girder bottom only, both will be a separate object and only they will be connected by the bottom. The substandard is composed of the abutment which we have made 4 cross 2. The total length is 33, while the foundation spring is made up of foundation spring. So our girder will be placed on abutment, and abutment will be separated by the foundation spring. Select OK and OK. The next step is to define the bends. But before we need to define the bend, we will define the column, bend column and bend. Define section, frame section, a new property, concrete, select circular, rename the column as column 2. The size will be 2 feet. Press OK. Now add a new property, concrete. This and it will be rectangular, and the name will be bend cap. Size will be 4 cross 2. And here, for easy recall, we will place here 4 cross 2 as well. Press 4 feet and the width is 2 feet. Press OK and OK. Now we are ready to define the bend. Bridge, bends. Add new bridge bend. From here, first of all, we select how the bend is connected to the deck. It is integral part of the deck, so the girder is resting on the bend. So we select connect to the girder bottom only. Now the cap beam length is 33, and number of columns are 3. The cap beam section is made up of bend cap 4 cross 2. Now here bend type can be single bearing line, double bearing line. Single bearing line means that the slab, deck slab is continuous while double bearing means that the two span slabs are discontinuous. Both spans, the slabs in both spans are not connected together. Now here we will modify the modify show column data, and the column is made up of column 2, mean column 2 feet. We also need to change the distance of the column.
That means all this thing we should perform at hand.
Yeah, bring the laptop yourself next time.
I mean, all this value you should have it
But
in
you
the
should,
paper
yeah.
before.
In the project description, I gave you all those things.
Distance for columns are 4 feet. First distance is 4 feet. The second distance is 16.5 feet. And the third distance is 24 feet. Second distance is 16.5, while the third distance is 29 feet. Heights are also equal. First height is 21, second height is 27, and third height is 30. The support condition is fixed, fully fixed, and the base of the column is also fixed. So it is fully fixed from the base and fully fixed from the top of the column. That's OK and OK. Now here we have defined the bend as well. Now next step is to go and define bridge object. In the bridge object, first we have defined the layout line, section, diaphragm, foundation, bearing, abutment, bend. Now in the bridge object, all these components will be combined together in a single bridge object. SAP uses this bridge object to make the SAP object from the bridge model. Go to bridge object, add a new bridge object. Now first step is to select the span. We will start from a span of 1000 and span will be at 1100. While intermediate span will be at 1050. So we have the start with abutment, intermediate span with end bend and span to end abutment. By modify and show, we can add the variation in the cross section of the deck section. But for our example, we have a constant cross section. So we'll leave this. Now the next step is to define the abutments. Select the abutment, modify and show. From here, we are giving the abutment straight. In the diaphragm property, we select the diaphragm, which we have defined. In the abutment property, abutment is already selected. Now we need to define here the elevation of the abutment. The elevation on the top of abutment is minus 4.2417. This is the distance from the top of the deck. So this distance is minus 4.2417. The bearing property is BBRG1, which we have already defined. The elevation of the bearing will be 6 inches less than this distance. So it becomes minus 3.7417. We'll change these values for the end abutment as well. Select end abutment. Diaphragm property is B dia 1. Abutment type is abutment. Elevation of the abutment from the top of the deck is minus 4.2417, while that of the bearing is minus, which is 6 inches less, is minus 3.7417. Press OK. So the next step is to define the bend. Select the bend, modify and show. The diaphragm property is B dia 1. The bend is made up of bend, and the bend elevation are the same, which is minus 4.2417, while that for the bearing is minus 3.7417. The bearing property is BBRG1, and we will keep the rest of values as default. Press OK. Now, up to this step, we have defined all the components in a single bridge object. Now, our model is ready to convert from the bridge object into a set object. Press OK and OK. Now go to bridge and update link bridge object, and maximum number of length expand as 5, and we'll use spine model. Select OK. So our bridge object is made from spine. By spine, it represents a single line. We can extrude this and check our model in OpenGL. Switch back to classic perfect view and close one of the window. Now we can also model our structural element as area object. Select area and press OK. Now here our model is made as an area object, and we are looking at extruded view. In OpenGL view, it will look like this. This is the OpenGL view. Now in area object, the bridge is not considered as a land object, but it is a 3-dimensional object. Switch back to the classic view. We can also model our bridge as solid object. Here we have defined all the components, all the components required to model bridge. And this concludes the tutorial.
Okay, this is how to make a model for the bridges.
I mean, we should design by the hand, then plug in the data.
Hmm. We can compare by the hand, like shear force bending moment diagram, influence line diagram. We can see. Okay. So this is your course project. Here, this is a bridge model. Okay. So this is girders, 5 girders, 6 girders, and this is S1. Okay. This is also taken from the book, the same book we are using. You can make the model by using this cross sections and loads. Okay. This is one part. The second part, maybe the analysis part. So let's also run the analysis part also.
In this video tutorial, we will perform load analysis, volume load analysis, we will show the two modes of damage analysis, and we will display the output. So let's get started. Before loading our structure with live load, we would like to check our model with the blend load. So go to bridge, update lean bridge model, select update as spine model, press OK. Uncheck the extrude view. Now our model is behaving like line element. Bridge is represented by a line element. Run the analysis and uncheck model to do not run. Run now. The deform shape for the whole bridge deck and the mirror is shown.
We can see the maximum deflection, and we can also compare it with the calculation.
Frame given. Press OK. This is the diagram for the bridge deck and mirror. We can also perform the analysis using area object. Allow the model. Go to bridge, update link bridge model, and update as area object. Run the analysis. Now in this case, we can see the bending moment diagram of individual girder. We can check the stresses and forces in the deck as well. the next part is to define the bridge live load. In the bridge live load, the first step is to define lane. Go to bridge, lane. First we unlock the model, bridge, lane. Add new lane data. We'll use the existing bridge layout line defined earlier. The starting station is 1000, ending station is 1100. Lane width is taken as the center line offset will be taken as 8 feet, while the lane width is taken as add. Now we provide the end station. The end station is 1100. Center line is 8. Width is 12. Add. So we have defined the lane. It is represented by the green color. We can change the color from here and change the color to the yellow. So now add a copy of a lane, and we will use an offset of -16. So we have another lane from opposite on the second line of the bridge. We'll keep the default blue color and press OK. Now here we have two lanes. And we can check the lane by width by display show lane and show lane width. So here we have two lanes defined. After defining lane, we will define the vehicles. Bridge, vehicles, we will add 3 vehicles. All of them will be as general. Add standard vehicle, add HS2044 and convert to general. Now we can see this vehicle. Here we have 2 points. We will change these 2 points to the fixed line width. Select and fixed line width, modify. Fixed line width, modify. And fixed line width, modify. Here the points are converted to the width. Press OK. Now we'll add 2 more vehicles. Add a vehicle. The second will be HS1044N. Convert to general, yes. And add another name, convert to general, yes. And press OK. After defining 3 vehicles, we will add a vehicle class. In the vehicle class, we will include all these 3 vehicles. Bridge, vehicle class, add a new class, and add the defined 3 vehicles. Press OK and OK. Now we are ready to perform the moving load analysis. We need to define the load case for moving load. So we go to define load case, add new load case. The name of the load will be moving. The name of the load case will be move 1. class is included on both lane 1 and lane 2. Press OK and press OK. Define also load combination. Define load combination. Add new component. The component add the depth load as well as the making load. Press OK and OK. Now run the analysis.
How much time it will take? Maybe 2-3 minutes. Estimated time.
Almost 90 minutes.
If you have the most dense mesh, it will take more time. Some years before, one group was doing STP and Belgies. He make maybe 7 or 8 span, so it will take 1 day.
One day?
Yes, so you can sit with the computer till the analysis will finish. So fast computers are required when the process. Can you completely, so the tools is not too much.
Here we are looking at the force in one direction to dead load. Change this to combo. And F11 will see the force 11, force in the lower axis one direction due to dead and moving load. We can also check the control lines, the influence lines. Influence lines selecting the location will be moving load. We need here to select the joint for which we want to plot moving load, the influence line. So select the frame, show its label. The label of this frame is 29, 28. Display, show influence line surface. We'll select lane, both lanes. We'll select frame. The label selected is already 28, and we want to check its shear force diagram, shear 2 and we'll plot as center line. We'll plot along the lane center line. For the move load case which we have defined, we can also check the table values for that. These are influence line values in the tabular format. Now plot along lane center line. So this is plotted along the lane center line. This is the center line of lane. This value and the second value here. These are now plotted as center line. We will fill this so that we can see clearly. Now we have two lines. And it is plotted on the center line of the lane. Go again, display, show influence line, and plot lane width as wireframe. Show wireframe back. Check this option. Now we can see the lines as wireframe over the deck. You can plot this as show influence line as contour, and we will show this as show wireframe as deck. So we can see the influence line as a contour map over the lane. This represents the shear 2 over the frame, which is highlighted at a relative distance of 0.5. unlock the model. Again, we can perform the analysis as spine model, but we will not go for this option at this moment. To see the vehicle response, we need to define load patterns for moving load. Define load pattern. Add a pattern by the name of moving. Type will be bridge live. Add modify. The vehicle is HSN44. It is only one. The starting time is 0. It is moving forward with a speed of 44 feet per second. Another vehicle is moving and the start time is 7. Second, it is in the forward direction with a speed of 44. The third vehicle is moving from other direction on lane 2. The lag time is 3 seconds and it is moving backward with a speed of 50. The duration of loading is 10 and discretization of load is at every point 1 of the vehicle. Second, press OK and OK. Before pressing this button, we would like to define another load case as a move. Modify it. Here we will have all the load in a single lane, starting by 0, forward, and for full speed. We will add another one with a speed of 88. The lag will be 5 seconds. The third one will be 9, moving forward at a speed of 176. And so now these three trucks are on the lane 1 and following the lag time forward direction with the following speed. Press OK and OK. Now we need to define the basis
We stop
for
here.
the newly defined loads. The moving load is defined as
Practice.
it is based on
Practice.
moving,
Practice.
while the move load will be defined as time history. The time history of direct definition is based on rank function with skill factor of 1. The time duration or amount of time will be 2 for
Okay, let's stop here. In the next class, we will continue, inshallah. Okay.
and output time step is 1.
So, how many of you are there?
7.
7. 1, 2, 3. We will continue in the next class. Okay. So, 7. I will take the attendance and we can leave. So Ahmad is here. Usama Akram is there. Amjad. Amjad is there. Amin.
Yes.
Yes. Ayub is here. Yes. Bakar. No. Botsara is here. Hatem. No. Zakaria. No. Sultan is here. Abdul Rahman is no. Abdul Karim is here. Abdullah is here. Fawaz here. Muslim? No. Muslim is not here. Musab is here. Musab, no. He proposed the classes. Oh, Muslim was there.
Muslim and Musab, doctor.
Musab is there. Okay.
Muslim and Musab,
Okay.
also Muslim.
Yes. Okay.
Okay.
Only Bakar, Hakim, Zakaria, and Abdurrahman were absent. Okay.
Hatem was here also.
Okay. Thank you very much.
Thank you, doctor. See you inshallah in class.